In the lesson today, we are continuing to solve systems of linear equations. The math idea is I'll understand how to write equations for word problems and solve a pair of linear equations to determine where two lines cross. We're not going to write word problems today, but we are going to solve systems of linear equations. There's several ways to do it. You can make a table and look for when the entries are exactly the same. You can graph them. That's where the two lines cross or intersect. But we also can use equal values. So that is one of the methods that we are practicing. So in the first one, I just give you two equations and I want you to make the tables. For the y equals 2x plus negative 6, you can do this in a couple ways. You can substitute 0 in for x and find your y. You can do that for all of those. Or you can use the idea about y equals mx plus b, where the m, which is the number in front of our x, that's our growth. And the negative 6, that's our y-intercept or our starting value. So the first entry for this one would be 0, negative 6, because when I plug 0 in for x, 2 times 0 is 0 plus negative 6. That's the one way, or this is my y-intercept. And then it's growing by 2, so it'd be 1, negative 4, 2, negative 2. Those are coordinate points on the graph. The same thing for this equation. You should make a table, see where the entries are exactly the same. And then over here with equal values, to use the equation, what you're going to do is you're going to set 2x plus negative 6 equal to negative 3x plus 9 and solve for x. That would give you your x coordinate. And then because we're looking for a coordinate point where they intersect, you would then plug your x value back into each one of these equations and to see if you got the same y value, because it's a coordinate point. You can then graph these two. You could either graph them on graph paper or use Desmos.com to graph them and prove that. And then, so for the second one, sometimes they're not in the y equals mx plus b form. So first thing you need to do is adjust this second equation by adding 4x to both sides and then divide by 2. And once it's in slope-intercept form, and I would change that equation once you have in slope-intercept form. Once it's in slope-intercept form, then it's much easier to graph and find the point of intersection. And then, again, graph that on Desmos. And then I have one more on here where you have to first solve that for y, your second equation again, and graph that. And you're going to see, hopefully from this one, when you graph it and make your table, you're going to see one point of intersection. When you graph this one, you're probably going to see a set, hopefully you'll see a set of parallel lines. And that's what it looks like for no solution, because they do not intersect. And on this last one, hopefully you're going to see they come out to be the same line, and that's what it looks for infinite solutions. Hopefully that helps.